Yes, we try to talk about standard free energy change. Standard free energy change. And I have already told you that whenever we are talking about standard, we put a degree over it. Okay, for standard free energy change. What is standard free energy change? Let us try to understand. So, as I have been discussing, that in order to have standard, the conditions maintained should be at 298 Kelvin and 1 bar pressure. So, whenever we maintain the pressure to be 1 bar and the temperature to be 298 Kelvin, the free energy change for a process will be called as standard free energy change. The free energy change for a process at 298 Kelvin and 1 bar pressure the free energy change, you include the word change. The free energy change for a process at 298 Kelvin and 1 bar pressure in which the reactants in their standard states are converted to the products also in their standard state is called standard free energy change. Delta G degree. So we can write for any reaction the delta G degree, here small r stands for any reaction, is equal to summation of delta F G degree of products minus summation of delta F G degree of reactants. Same way that we discussed for calculating delta H degree of any reaction. So it is always the formation of products minus formation of reactants. So the questions that are generally asked under this topic is either it will be based on spontaneity. You need to calculate the temperature at which the reaction will be spontaneous, or you need to predict whether the reaction will be spontaneous or not. And second type of questions that will be asked will be based on calculating the standard delta G degree of the reaction. So then I'll give you and we'll discuss some questions based on spontaneity of a reaction. Tell me after you have completed writing, then we can proceed further. What is the meaning of sigma? Can anyone tell me? Sigma mane ki? No idea. Abhilash, can you tell me what is the meaning of sigma? If no idea, please tell no. If you know, you tell me yes, and what is the answer? Yes, tell me, what is the meaning of sigma? Sigma is used in statistics. Bipasha, do you know?
No, sir.
Okay, so you should tell me. Suppose you have a reaction A of A plus B of B giving C of C plus D of D. So this is a reaction. And you are asked to calculate the delta G degree for the reaction. So we need to apply the formula. And if we want to apply this particular formula on this reaction, so delta G degree, delta R G degree will be summation of, who are the products? Tell me, A and B or C and D?
C and D.
C and D. So we are going to calculate the delta F G degree of C multiplied with the number of moles plus delta F G degree of D multiplied with its respective number of moles. So we have added up the standard Gibbs free energy change of formation for both the products. F stands for formation minus, what should I write next? Tell me. Products are over. Now what I am supposed to write?
Sum of reactants.
So A into delta F G degree of product reactant A plus B into delta F G degree of B. Clear or not? Now is it understood what is the meaning of summation? Sigma mane summation. Summation of the products minus summation of reactants, and don't forget to multiply the respective number of moles, because each and every reactant is important as it is an extensive property and depends upon amount of substance. Clear?
Yes, sir.
Okay. Can I proceed further with the numericals so that you can understand it better?
Yes, sir.
Okay. Right. For the reaction at 298 Kelvin, twice of A plus B gives C. Delta H equal to 400 kilojoules per mole. Delta H equal to 400 kilojoules per mole, and delta S equal to 0.2 kilojoules per Kelvin per mole. At what temperature will the reaction be spontaneous? Okay, so you need to calculate. So this is the type of question I was asking. I was talking about that such type of questions are asked under spontaneity. Okay, now tell me, out of the two, delta H and delta S, who do you think is favorable and who do you think is unfavorable?
Delta S is favorable
Why?
because it is positive.
Yes, very good. So both are positive, but delta S positive is favorable, delta H negative is not favorable. So what I'm going to do is, let us assume the reaction is at equilibrium. Let the reaction be at equilibrium. And we are going to calculate the equilibrium temperature. That is delta G is equal to 0. Okay. So if delta G is equal to 0, so can we say delta H minus T delta S is equal to 0? Yes or no? Because delta G is equal to delta H minus T delta S or not?
Yes, sir.
Okay. So we are going to calculate the temperature at the borderline. So we can write delta H is equal to T delta S. Or we can write T is equal to delta H minus delta S. Put in the values. It will be 400 divided by 0.2. Both the units are kilojoules. Sometimes one is in joules, other is in kilojoules. You have to convert both of them to the same unit. Here it is not required because both of them are in kilojoules. So ultimately, how much is the answer coming out? It is 2000 Kelvin. Clear?
Sir, why delta G 0?
We have assumed the reaction to be at equilibrium. At equilibrium, delta G is 0 or not?
Yes, sir.
For spontaneous reaction, delta G is what? Negative. For non-spontaneous, it is positive. And for equilibrium, what is it? Is it not 0? So we have assumed let the reaction be at equilibrium, for which delta G will be 0. Clear or not? Okay, now tell me, this is the equilibrium temperature, 2000 Kelvin. But the question asked is, what is the temperature at equilibrium? This is not asked. From our own side, we have assumed that let the reaction be at equilibrium. What is asked in the question is, at what temperature will the reaction be spontaneous? Now, who is favorable out of the two you have said?
Delta S.
Delta S. So should the temperature be higher than this temperature or lower than this temperature to make the reaction spontaneous?
The high.
High. Why? Can you tell me why?
Because the temperature supports the delta S.
Very good. Excellent. Because the temperature supports the delta S and delta S is favorable in this case. And therefore, we can say that the borderline temperature has been calculated. So therefore, the reaction will be spontaneous. The reaction will be spontaneous above 2000 Kelvin. Clear? Understood or not?
Yes, sir.
And if the temperature is below 2000 Kelvin, then what will I write? The reaction will be non-spontaneous, isn't it? So
Yes, sir.
exactly at 2000 Kelvin, the reaction is at equilibrium. Delta S is supported by temperature and delta S is favorable. So temperature should be supporting the delta S. Therefore, we should increase the temperature. So above 2000 Kelvin, the reaction will be spontaneous. Understood?
Yes, sir.
All of you are clear now how to calculate the temperature for spontaneity? So always calculate for equilibrium and we will equate delta H minus T delta S equal to 0. And thereafter, the temperature will be increased or decreased and based on that, we will be calculating. Can I proceed further? Is it okay? Are you comfortable?
Yes, sir.
Okay, fine. So we can expect one question of this type under Gibbs free energy. So Gibbs free energy is an important criteria to predict the spontaneity of the reaction. Let us move on to next type of reaction. Next type of question. At 0 degree Celsius, ice and water are in equilibrium and delta H equal to 6.06 kilojoules per mole for the process H2O solid to H2O liquid. What will be delta S and delta G for conversion of ice to water? So directly by looking at the conditions, we can say what is delta G. Can anyone tell me what is delta G for this reaction? Anyone?
Sir, delta G equal to delta H.
No, what is the value of delta G?
So 6.06.
No. How can it be 6.0? Delta G? Huh?
Sir,
Zero.
0. Since
0.
they are in equilibrium.
Yes, they are in equilibrium. So because the reaction at 0 degree Celsius is at equilibrium, so delta G is 0. For reaction at equilibrium, delta G is equal to 0. So therefore, delta H minus T delta S is equal to 0. So what you need to calculate is delta S. So therefore, delta S will be delta H by T or not? Yes.
Yes, sir.
So 6.06 and temperature is how much? 273 Kelvin. You should not consider temperature in degree Celsius because it is always to be considered in Kelvin. So 0 degree Celsius has to be converted to Kelvin. Otherwise, it will become infinity. So rest is calculation, how much it comes out. It will be nearly 0.02219 kilojoules per Kelvin per mole. And if you want to convert it into joules, multiply it with 1000. So it will be nearly 22.19 or 22.2 you can write joules per Kelvin per. Clear? Is it understood or not?
Yes, sir.
Okay. So mainly you'll have to remember that at equilibrium, delta G is 0. And with the help of delta G equal to 0, we need to calculate the delta S or delta H, whatever is asked for. Rest everything has to be given. Next question. A very important question. For the reaction, twice of A gas plus B gas gives twice of D gas. Delta U degree, means change in internal energy, standard internal energy change is minus 10.5 kilojoules. And delta S degree minus 44.1 joules per Kelvin. Calculate delta G degree for the reaction calculate delta G degree for the reaction and predict whether the reaction is spontaneous or not. Okay, so this whole question is a package in itself, and you need to calculate delta G degree. But for calculating delta G degree, what things are required? Tell me. What things are required for calculating delta G degree? Can anyone tell me? Is delta U degree required or something else is required? Yes, tell me. What is required to get the value of delta G degree? What is the equation for delta G degree? Anyone? Delta G degree is equal to what? Is it not delta H degree minus T delta S degree? Yes or no?
Yes, sir.
But is delta H degree given?
No, sir.
Anywhere? No. What is given instead? Instead of delta H degree, what is given?
Delta S degree.
Delta S degree to required. But this is required. But in the question, instead of delta H degree, what is given? That is what I am asking. You require delta S degree, that's fine. But we require delta H degree. But in the question, is delta H degree given or something else is given?
Delta U degree.
Delta U degree is given. Delta U degree is not required for getting the delta G degree. But with the help of delta U degree, we can calculate delta H degree. What is the relation between delta H degree and delta U degree? delta H degree is equal to delta U degree plus delta NGRT. So in the initial phase of thermodynamics, we have come across this particular reaction. So how, with the help of this, we can calculate it? Delta U degree is minus 10.5 into 10 to the power 3 joules per Kelvin per mole. Tell me, what is the delta Ng for this reaction? Change in the number of gaseous moles is how much?
Sir, -1.
-1. 2 minus 3 minus 1. The value of R in terms of thermodynamics is 8.314 joules per Kelvin per mole. How much should be the temperature? Temperature is nowhere given, but we can put in the temperature. Tell me how much temperature we can put in. किमान temperature लिखी बा? Anyone? No one. Bipasha, help me out. How much should be the temperature? Any idea? Shorojit, Nishu, there are so many people attending the class. How much should be the temperature? Abhilash, any idea? কিমান হ'ব temperature? ডিগ্ৰী আছে না নাই? ডিগ্ৰী থাকিলে temperature কিমান হয়?
298.
298. Temperature is standard temperature. Okay. Now you calculate this value and tell me how much is delta H degree coming out. Quickly do it. This is 10,500 minus how much this comes out? 298 into 8.314. I think it is 2477.572. So it will be 12,977.572 negative joules per mole. Okay? Are you getting this? See. Check it out yourself. I may be wrong.
Yes, sir.
Can I proceed further? Now, delta H degree is known to us. Yes or no? So if delta H degree is known to us, with the help of delta U degree, we have calculated it. Now you can apply this equation. So therefore, delta G degree is equal to delta H degree minus T delta S degree. So delta H degree is minus 12,977.527. Temperature is 298 Kelvin. And how much is delta S degree? It is given in the question. How much is the value of delta S degree given? Tell me.
So minus
4.1.
Minus 44.1 joules. Okay, so this is also in joules, this is also in joules. Get me the value of delta G degree, how much it comes out, tell me. So it is minus 12,977.527 minus of minus plus 298 into 44.1. Anyone calculate it and tell me how much is the value coming out? Minus 12,977.527. How much is this value? Has anybody calculated? Tell me.
Sir, 13141.8.
13141.8. Okay. So what is the net value coming out? Net value will be positive or negative?
Negative.
This value is greater than that of this, I think. Nah?
Yes, sir. Positive.
Positive.
Okay. So in the question, you were asked to calculate what is delta G degree. And you are also asked to predict whether the reaction is spontaneous or not. So what can you say about the reaction? Is it spontaneous or non-spontaneous? What do you think? Is it spontaneous or non-spontaneous?
Sir, non-spontaneous.
Why?
Sir,
Since delta G degree is greater than 0, the reaction is non-spontaneous. Clear or not?
yes, sir.
To prepare these type of questions on delta G type, delta G related questions, or you will be asked to predict the spontaneity of a reaction, or you might be asked to calculate the temperature at which the reaction will be spontaneous, or you might be asked question of this type. So this is a very, very important question from NCERT. So it has high possibility of being asked. So always remember that the 4 different types of thermodynamic quantities that we have come across are change in internal energy, change in enthalpy, change in entropy, and change in Gibbs free energy. These are the 4 important thermodynamic properties. The relation between delta H and delta U is delta H is equal to delta U plus P delta V, or delta U plus delta NGRT. This is the relation between delta H and delta U. The relation between delta S and delta H is this. Delta S equal to delta H by T. And relation between delta G, delta S and delta H is this. So these are the relations, and you can see that who is the common between all of them, which can help to join one with the other. Who is the common thermodynamic property in all these equations?
Delta H.
Delta H.
Delta H.
So enthalpy change is the common factor between all the different thermodynamic properties. And just now, whatever question we have done, you are given delta U and delta S, with the help of which delta G was to be calculated. When it is at standard condition, it becomes degree. Rest everything is same. So with the help of delta U, we can calculate delta H, and after that we can put delta H value to get the value of delta G, because as such both temperature and delta S was known to us. Here.
Yes, sir.
Okay.
Yes.
So this much you prepare for thermodynamics. Not more than this is required. And please watch all the videos and accordingly you prepare. Okay. Thank you. Good night.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.